Hello hires, so we're now looking at the data handling from the 2011 past paper, question 6. Right, this is context. The compensation point is the light intensity at which a plant's carbon dioxide uptake by photosynthesis is equal to its carbon dioxide output from respiration. In some plant species, compensation point can be reduced when the plant is moved from bright light to shaded conditions. Okay. Now this is not part of the content anymore, it used to be. But they're quite happy to put it in as a problem-solving question because they're giving you the information. So you need to really put that in kind of proper context in your head. So what they're telling you is there is a point at which there is enough light to produce the food from photosynthesis that is equal to the amount that's being used in respiration. And they measure that in terms of carbon dioxide going in and carbon dioxide coming out. So what they're saying is, at that point, it's exactly balanced. Every single bit of carbon dioxide that's being taken in by the plant is being used to produce food, which is then being pushed through respiration, and carbon dioxide is then being produced. Okay, so graph 1 is the compensation point of 3 species of plants over a 25-day period when they're moved from bright light into shaded. And I don't know if there's a good graph or a bad graph there. It's not a double axis, which is an improvement in some of them, but you do have 3 different lines. So you've got, this is your weeping fig up here. You have the rubber plant on this section, and we've got the spider plant down here. And we've got the compensation point, so the point at which they manage to balance out their respiration and photosynthesis, and it's going up in, what's that, going up in 25s. Not a bad scale. It could be worse. It's a reasonable graph, single axis, but 3 lines on it. This should no longer surprise you that we're starting off with a describe question from the graph. So we have the weeping fig, and you're asked to describe its changes over the 25-day period. So we have this point to this point, because that stays the same, so that has to be given. You then just need this point here, because this is a trend that is a downward trend. You could put this point in, you don't have to at all. I would avoid it because you don't want to make any reading errors. And then we have stays the same again. So these 4 points, which again should not surprise you, it is worth 2 marks, and that's been pretty much the consistent thing they're asking you to do. So we have at 0 to 5 days remains at, what are we reading? These, what did I say, going up in 25, so that's 1375 light intensity units. Remember, you have to give your units somewhere. Then falls to, and what have we got here? Can't seem to get that to read cleanly. What's that? 450 units by day 15. Then remains, same to day 25. There we go, there's your points. Percentage decrease. Yet again, I'm saying as a hire, the likelihood is this is what you're going to get. So compensation point in the rubber plant, this dude here, and we are starting here and we're going to here. So its start is 1250 and its end, trying to read cleanly. So it's not the easiest on the screen. I really get that for those of you who are working from these. So it goes to 500. So we have, I'm just going to grab my calculator, although it's not too bad a sum. So we've got 750 is the change, divided by our start. I'm just going to put that up there, because change divided by start times by 100, that is always what we're looking for percentages, or percentage change rather. So 750 divided by 1250 and times by 100 gives you 60%. Right, predicting the compensation point of the spider plant at 28 days. Now, you'll get to the point where you'll recognize that's probably going to be a likely question when you're given a graph with this kind of gap at the end of it. The only thing they can ask you to do is extrapolate, and it's going to have to be an extrapolation. So 28 is, there's 29, there's 28. So they're asking you to extrapolate back using this line, keeping it as neat as you possibly can. It's really quite tight. Okay, so I think it's there, but it could be there. And this is where it's difficult to do it exactly on a computer screen. If you had a printout of this, then you would have a ruler which would be allowing you to actually run it. It's actually maybe that point, yeah. So I think it's 50 on this. I'm going to accept 25 just because on the screen I think it's very difficult to read it. I'll check the mark scheme, but I think the mark scheme was saying 50. Okay, use evidence from the graph to explain why the rubber plant could not grow successfully in a constant light intensity of 400 light intensity units. Okay, right, this is worth 2 marks, so you're going to have to do a little bit more than just read off a number. But here is our number. So our number is 400. So 5, 1, 2, 3, 4. There's our 400. So here's our 400 line. So if I take this across, just so I can see what's going on, there's my 400 again. So why the rubber plant? So the rubber plant is this dotted line here. So you're going to have to go back to the original context to be certain you know what you're talking about. You will see here that if it was 400 light intensity, that this plant never reaches its compensation point. So that means it never actually gets to the point where it is doing enough photosynthesis to balance out its respiration need. So it would use up all of its stores of energy, and then it would fail to compensate for the fact that it's actually living. So it's going to fail. So you need to put those 2 points together. So you need to put down the point that you have that it is never reaching its compensation point, that 400 is below the compensation point, the point at which it is producing enough energy by photosynthesis to balance out the energy use by respiration. Okay, so the second point is the balance bit. Right. After 10 days in shaded conditions, a plant of one species was placed into different light intensities and its carbon dioxide output and uptake were measured. This was repeated with another plant of the same species which had been in the shade for 20 days. Results are shown in graph 2. So this is a totally different graph. Right, so we have 2 lines on this. We've got a 10 days in the shade and a 20 in the shade. And along here we have the light intensity. This is definitely a higher graph because we've got an axis which is at 0 and we have uptake going this way and output going this way. So effectively we have a negative and a positive part of the graph. So these points here, this point here where we have nothing, no input or output, that must be the balance point. That must be where for every bit that's being taken in, there is a bit given out. So therefore it overall means that you have nothing. Okay, so that's the compensation point. Use all the data to identify the plant species referred to in graph 2. So all the data means I'm going to have to use both my graphs. I apologise if these are a little bit small. I'll see how I can read them off. It was trying to get them onto the page. Okay, so we are looking for the plant species now. So I told you there's actually only 2 data points we have here, these points here. So at 10 days in the shade, we have 500. So 10 days, the compensation point was 500 light intensity units. At 20 days in the shade, this point here, we have, so 20 days is 250 light intensity units. Right, okay, so now we go back to graph 1 and you look for 10 days, this bit here, and we're looking for 500. Oh, there we go. If the next one fits, we know this one's right. Okay, because this one's definitely too high and this one's too high. So we look back at our 20 days. Here's our 20. We're looking for where that crosses, and there's 250. Right, spot on. Right, we know exactly what that is. So that is the spider plant. Give a reason, and the reason is at 10 days the compensation point is 500, and that is the point at which you have 0 on this graph, or you use the 500 one, or you talk about both. Okay, we're looking for how many times greater the carbon dioxide uptake of this plant was at 1000 units of light intensity after 10 compared to 20. Okay, so I'm looking for my 20 to start off with, because I'm looking for how much bigger the next one is. So there's my 20 at 1000. Read that across a little bit footery. I'm actually just going to count it down. So it's 2 down, so that's 40. So it's 40 at 20 days in the shade. 10 going up the way here, so 1, 2, 3, 4 up, so 70. So that's at 70. How many times greater? So 70 divided by 40 gives me 1.75 times greater. Here's your mark scheme. I would say obviously the longest one they have there is part 4 on question A, that you're requiring those 2 points. And otherwise I think it's reasonably straightforward. And that's another problem solving down.